Morning everyone. I'm Tanay and welcome to the fourth edition of Expert Talks Goa. A little bit about Equal Experts as a company. We are a software consultancy and we. Oh, hi! Hello. Okay, have a seat. We are a software consultancy and we deliver like agile solutions to our clients. Less about Equal Experts and more about Expert Talks. Expert Talks is a community event where we try to build a tech community, and over here what we are doing is attempt to build a tech community in Goa. So feel free to use the breaks in between the talks to socialize and build your networks. And I hope you enjoy the talks today. So for the first speaker of today, we have Kavita. She has come all the way from Haryana to Goa to deliver the talk to you. That's it. I'll hand over to Kavita. Let her take the stage.
Hello everyone, thanks a lot for coming on weekend. Today's topic is data migration with zero downtime. So today I will be sharing my experience how we were able to do the data migration between the databases and between the microservices. That too without having any impact on the customer availability and the data integrity. So as we all know, data is very important asset in every company, and doing the data migration is something which can be a bit risky because this can have impact on your actual customers and the data integrity as well. So today I will be sharing my experience how we were able to do it. This will be the agenda, the use case. I will be sharing the two use case, tools, architectural rollout steps, the integration strategies and the factor we should consider during the migration and our learnings. In the end, we will be doing the Q&A. Let's get started. The very first use case is doing the data migration from SQL to NoSQL database. Scale, if we just talk about here, is we were having three main tables. The data size was around 7 billion records, and the service was taking around 5 to 7K requests per second, and the data was distributed across 3 different regions and the environments. If you look at the scale, this was the normal days scales for that service. And if I just talk about the service, the service was taking care of the authorization of all the media that is being available on that site, and every request that goes to read or write any data, any media. So this was the service who was taking care of if that user have the access to actually read that particular resource. Because this was the main service, we cannot compromise on the latency, so it should not go beyond 100 millisecond. And also, the main challenge was that because it was related to the customer data, like it should not be the case like if someone uploaded a particular image or any media and they don't have access to that, so there should not be any impact on the customer data integrity. And also we were having a constraint of time to market because of their existing infrastructure. The service was having a downtime of around half an hour for if there is any load or if there is any unexpected thing happens, then service was having a downtime of around half an hour every month. So this is something they just wanted some quick solution so they can avoid this downtime and also save some money. The solution that we use for this is DMS. This is something offered by AWS. I will be sharing a bit more about DMS, but the main thing is when we use DMS, it was a very new offering and it was not something with very battle tested with so many use cases. We did like lots of testing before we use that. So a bit more about how did we solve this thing is with the DMS. It's a data migration service fully managed by AWS. With DMS you can do migration in 2 ways, full mode plus CDC mode. Full mode is something that you migrate your existing data to the destination database. CDC mode is something that you actually migrate which is currently coming in your system and you need to directly put it in the also need to put it in the destination side. The one that we used was full load plus CDC because we needed to migrate the existing as well as the ongoing data. So yeah, this is what we use. So it can support any homogeneous and heterogeneous database. You just think about any database, and DMS should be having a support to actually do the migration with that database. And it's fast and secure. Just to share the numbers, we were able to migrate around 5 billion records, that too within just 2 days. With it, what does that mean? We were able to migrate around 50,000 records, 25,000 records within 1 second. So yeah, it's fast and secure. How DMS works, like what all components are there. So you need to define source endpoint where you will let DMS know what is your source endpoint, how DMS can connect with it. If there is any username or password required, then that should be set in this. It also provides you to give access for a particular role, and that role is having only the access to actually talk to your source endpoint. So once you define your source endpoint, you will be defining your target endpoint, very similar to source endpoint. Like here you will be defining what will be the what is your destination database and how DMS can connect with that, again defining some rules so DMS can get an access to actually to that particular database. Once you define that, you need to define the replication task. Replication task is something where you are configuring the detail about your DMS migration. We'll talk about more what all things that we can control with replication task. The next and last thing is replication instance that where you define your replication task. Here you can actually select like what kind of instance that you want. Either it should be CPU heavy or memory heavy. So depends on your source and target endpoint, you should be selecting the respective replication instance, and then you should be testing this throughout, like before you actually start doing it on the production. About the task that you can define the full load or if you want it to be full load or CDC. You can control the table schema of the destination table from here. Like if you don't want to priorly define your destination table, then here you can simply define it. You can also define what is the log level that you want to set. For example, if it should be very less logs or you want the detail logs, this is something that you can control. And you can also specify what should be the destination for that. The next thing is you can also control, how much parallel threads that you want to run to fasten up or slow down the migration, depends on your the availability of your resources. You can define what should be the error behavior. If anything is not happening as expectation, then you can configure your DMS tasks to actually control in a way that it can stop in between if something is happening unexpected. You can also define what should be the validation criteria to make sure that if your task is complete or not, and it also see the how many records that is being actually migrated. So yeah, this is about the task configuration, and this is ultimately it looks when you have everything defined. You just need to click one trigger and it will just simply start the data migration. So this was the first use case, and with DMS we solved the full load data migration and CDC data migration. The second use case is migrating data between the microservices. So here if you see, the scale was 3 tables, 5 million records, 2 environment. The scale is comparatively less as compared to what we did on the other side. But here the main, I think the service was very important to the company, because with this service they were making money. With this service they were actually onboarding their new customer, also their new product to the system. And the main challenge was the data modeling, because here the data was not sitting at one place. The data was distributed across the different services, and we were having a dependency on the different microservices to actually read that data. And also once we read the data, After the migration, we also needed to do some data verification just to see whatever we are putting, if it's consistent or if it is correct or not. So these were the few challenges, and how did we solve this thing is we created an in-house solution. And to create the in-house solution, you need to first identify what all APIs that you need to actually put down that data in the right state, or what should be the schema. And once we identify the API, then you also need to implement the migration interface layer. What exactly migration interface layer is, I will share in a bit. But with this, you can actually enable your existing system to provide dual reads and dual write with your live traffic. And then once you have that, you also need to have some kind of transformation rules, so you can read and write data as per your new model and old model within the same system, and you can do the transformation so there is no impact on your customer. And once it is done, you also need to have some kind of bulk migration batch job. So you can actually, because in this case we were the one who actually wrote the bulk migration thing instead of using the tool. So we wrote the bulk migration job to actually transfer the persisted data. During this thing, we just need to make sure that because we will be dealing with the huge data, but there should not be having any impact on the existing transaction that is happening on that database. So these were the main things that you need to take care during the in-house solution. How did we define the architecture is something like this. So here, if you see, this is very basic architecture that you see. You have the presentation layer, business layer, DB access layer, and the old database. But to support the data migration with this infrastructure, you need to integrate a data migration interface along with the feature flag service. So here, the interface will be reading the data from the feature flag service to see if it should be connecting with the old system, new system, or both the system. So it depends on the different phases that you are in your migration. You will be relying on this feature flag service to decide from where you should be reading the data. So once you have that in place, once you have that interface in place, then you will be mimicking the existing interface implementation in the new model. So that new implementation will be actually connecting with, will be having exactly same methods what you have already in your old system, and that will be connecting with your new database or new service, depends on your use case. So here, once, like, if you see the maximum changes that we are doing only on the new part. So we are just making sure that there is no impact on the customer usability. So on the left side, we decided to not do any kind of changes. So if anything happens, something can be controlled with the feature flag service. And if the service needs to have any external service communication, then this is the only piece which is actually connecting with that service and controlling if, controlling if anything happens, then that should be very easy for us to actually roll back the changes. Once you integrate this thing, which means that you are allowing your service to actually connect with the new system that is with the live traffic. But to do the data migration for the existing traffic, you need to have some kind of bulk migration job, which will be reading the data from old system to the new system. In first use case, we use DMS to do this job. In the other system, we created our own API to read the data from one database to another database. And also you will need the data verification thing, because once you migrate the data, if the transformation rule is working as expected, if you have all the records or not, you also need some kind of data validation. So this is also in the background, you will be having some kind of data verification job to see if your migration is fine, and also the live traffic is also writing the data as we expect. So this is the architectural changes that you need to put in your system to do the data migration. How did we roll out this? So how exactly this will look in the code is Like for example, you have an interface, you have two main methods like write and read. So in the old processor, you will see that the write method or read method is only connecting with your DB layer. So there is no magic here. It just try to be an bridge between the old processor, old DB implementation, and for the new process, again you will be using that same methods, and you will be writing what all code is required. Here you will be consuming your transformations. So once you have this, then the dual write thing is, so in dual writing you see that we have the old processor, new processor in this, and you first will be reading the data from old processor, and then you were checking what should we do, like if it should be also reading the data from the new processor or not. If yes, then it will simply read the data. If there is anything unexpected happens, it will just simply log the data, log the failure, and also we will need to configure, if we want to have some kind of alerting in this case. Once we read the data, we will be comparing the data, and also depends on what should be returned. Again, in the different phase of migration, you will be returning the data. What all steps that we took, I will be sharing in a bit, but this is on high level how it will look. Similarly, you will see write as well. You will see this is write, this is read. There is very minor difference between two. And this is how with the reading the feature flag, you will be deciding which interface implementation it should be consuming. So depends on the feature flag value. So yeah, this is the crunch of the data migration. Behind the scene, you will be using the same methods that is actually required. Now the rollout steps are, so this is the very first step. Like you have one sys service, you have one database, which is actually connecting with each other. The next thing is you are implementing some kind of service, you are implementing some kind of database, which is having a capability to consume the data that is already there in existing system. So you prepare your alternative DB and service. Now, once you have that, the next step is how you can start the replicating the data. So you will migrate existing data to the new database. The next thing is like you have here two options. Either you first migrate existing data, or you first migrate the ongoing data to the new database. In our use case, we actually tried both the approaches, because we just don't want it to have any kind of downtime. So with DMS, we got in support because it provides CDC. But on the other approach, we first wanted to get confidence on the existing, on the new implementation, and then we wanted to do the data migration. So here, if you see in the first step, you are first consuming the existing data. So you migrated first the old. So as soon as you trigger AWS DMS migration, DMS will have some kind of SHA maintain its own end. So it does know how much data it needs to actually copy with the full mode, and from what time it actually should be migrating the data with CDC. For full time is comparatively very fast as compared to the CDC, and CDC also consumes some of the memory in your database because it's maintain all the read-write logs, write logs majorly. So once this is done, the other thing is now you will start enabling your connection with the existing service to the new service. This you will do in the fail-safe mode. Like first you enable dual read-write but in fail-safe mode. What does that mean is, here we'll have a feature flag value. We will enable to start reading the new data or maybe writing to the new database. But if there is any error, then there should not be any impact on the ongoing traffic. If anything fails, it will just ignore, it should not be reflecting back to the customer. And we were having a proper observability in place, that we are actually letting us know that if whatever failure it is, we just make sure and we first fix that and then re-enable the feature flag. If this is not working as expected, we'll just turn off the feature flag. First we just fix this, then and do the cleanup, and then we again enable this dual read write. Once we start getting confidence in this, we just simply enable the dual write in 100% rollout. Depends on your use case. If your writes are not dependent or to each other, there is no transactional required, then you can also do it in the different phases. But we needed to do it in the 100% rollout because anyway we were doing it in the fail-safe mode. So if there is any impact, we were okay with that. The next thing you can do is dual read write enable in the progressive way. So depends on how much testability, like how long you want your data migration to go, and depends on how critical it is. You can decide to increase the traffic as per your plan, and you can start interacting with the new service. So once we enable the dual read writes, and we were having a comparison logic in the background. And once we start getting confidence that okay, this is working as expected, we don't have any much errors, and we are not getting any kinds of alert. The service availability is not getting impacted. Then we were also having a background job which actually reads the data from old database and also reads the data from new database and doing the comparison. If the comparison is fine, which means that whatever data is there in the source is same, have the database in the on the destination, then we are good. Otherwise, maybe we try to find out a pattern, what's wrong. Then we can see, if anything wrongs, we can try to see how we can fix it, and if we really need to redo this whole migration if the data is corrupted. So yeah, if all good, then we are good. We can actually move to the next thing, and once we get confidence, it's fine. Then now we can start relying on the new code. Now we can start consuming this in a normal mode instead of fail-safe mode. So if there is any failure, then we were also logging that part. But in our case, I think we did enough testing before we actually put it in the normal mode, and we were not having any failure in that case. Now we actually started progressively relied on the new database. Instead of we just going one way, we did first started consuming around 10%, then 25%, and that's how once we get the confidence, we 100% roll it out to the new database. And once we are in this state that this is also fine, the bulk migration is also fine, the live traffic is also fine, we are not getting any more mismatches. We were running this in this mode that if there is any failure in this mode, it will have some impact on SLAs, and we will get to know that this is not working as expected. But if there is no impact on SLAs, which means that it is working as expected. At this point, we can now stop reading or writing the data to to your old system, and only consume your new system. But you might choose to keep your old system for a while, depends on your use case. But once this is done, I think you are in a good position, and you can stop reading this thing from the database. So this is how we actually roll out our data, like our changes in the data migration thing. What all common strategy pattern that we see in both the data migration is that you need to come up with your new schema API, and also if new schema, because this is something is good to decide before, because once you actually migrate the data, then you might not have enough enough data to actually decide. Next thing is implement data migration interface. So as you see that you need that interface in between the new and the old database. So you can actually easily migrate between, navigate from the old use to the new uses. And next thing is you integrate the feature flag with the default value as old system, because ultimately feature flag is also a different service that we will be consuming. So we should be having our old, like until we get confidence, it should be having a default value as old system, because if the feature flag is not working as expected, then it might cause or call to the new system, and we might have some data inconsistency between the old and the new system, which is not bearable during the data migration. We should also use two-phase commit to actually maintain the migration status. This is actually will be helpful in case of to know in like during the migration we'll get to know how much data is actually migrated and how much data is yet to be migrated. And also once you are writing the data with the live traffic, there as well you need to be also updating the data for the existing data, so you get to know that if you have migrated that data with the live traffic, you are again not migrating the data with the bulk job. So this is, I think, very important, so you are not doing the same thing and there is no data conflict if you try to do it again. The source of truth will remain, the old system will remain the source of truth, and you should be doing like two-phase verification. One is with the bulk data verification job that we did. So in the first use case, because we were having billions of records, we did the bulk data verification in the batches. So we read some random data from the source database and the same data in the destination database and did the comparison. And because we were using the third like this DMS, and this was a pretty much, I think, tested. We actually tested it with a small data set and compared if it is actually migrating all the data as expected. So that's why I think we were getting a good confidence there. So that's why it doesn't make sense we reading again those 5 billion records and then migrating the data. So we did it in the chunks. So data is there as expected on the destination database. We did dual read write for ongoing traffic. So every data that we were reading with the live traffic, we were making sure that we read from both the system, and we are actually putting some logic to actually compare the data. If there is any mismatch, we were actually getting to know if some data is inconsistent between the two databases and what exactly the pattern. So these are the, I think, common things irrespective of if you need to do data migration between the databases or microservices. I think this is something that is actually required. What all factors that we should consider during the migration is the data modeling. Because once you are done with like data modeling is important, because once you are done with the data migration, once you decide to not write the data to the old database, you will lose the data integrity in that case. So whatever data needs to be migrated, you should be planning the data modeling, because data migration is not something that you will prefer to do again and again. Understand the existing access patterns, so you know that what all new data that you are like new schema or new API that you are planning to put, if this is able to actually handle the existing traffic or not. If there is any changes required, then first you will do the changes in the API, and then later on you will do the data migration. We should not be doing both the changes hand in hand, because otherwise you will not get confidence if there is something inconsistency because of the data migration or the new behavioral change that you did. And next thing is the data dependency. If there is any data dependency with different data service, then it's good to know before, because depends on that service availability, you will be planning your bulk operation. because there may be some situation that the other service is not actually able to take this much load, but you need to control your bulk operation. Depends on the service, depends on the different service you have dependency, and also on the existing traffic that you are getting. And your data will be in eventually data like eventual data consistency there will be there, because you will be writing in both the database sequentially. So once it is successful in the first database, then you are writing to the other database. So there will be some difference in the timing between these two databases. So the reading operation, the reading or bulk verification operation that you will be doing should be having that logic in place, that if there is any difference between the created at and between these two databases, then it is smart enough to actually handle those inconsistency instead of showing any false inconsistency. And you should not be having any customer impact, so your service availability should not get compromised during this phase, because whatever we are doing behind the scene is not something that should have any impact. Your observability as well, if you are having enough observability, you are actually logging all the mismatches, you have the dashboards to see what all API endpoints, if there is any impact on the latency, if there is any impact on the service the API failure. This is something that you are tracking and also can see if there is any impact. So yeah, these were the few factors. The difference between the DMS and in-house is, first is cost. DMS is very costly as compared to whatever we actually create in-house. In-house solution, I think this is just another few APIs that you will be running, but DMS you need to create that proper instance, and that will be costing just like another EC2 instance. Scalability wise, I think DMS is pretty fast because there is no dependency on with the live traffic. It can just consume any like depends on the instance that you select. You can scale your solution depends on your use case. In-house, I think you will be having some, maybe depends on if there is more live traffic, you might plan to increase those number of instances, but if there is any data dependency, then you might be having that constraint that you cannot scale it just like DMS do. So in terms of scalability, I think here in-house compromise. Integration wise, I think DMS you will need another, if you want to automate this, I think you need to have some kind of setup in this case. In case of in-house, I think again another API it will be very simple and straightforward to do that. Speed wise, I think DMS is very fast as compared to in-house. Data modeling, I think DMS doesn't provide you data very good options there. You cannot combine data from different services or different tables. It should be there in one table. And in-house, I think it's on us how we want to do, and we can plan accordingly. So these are the few differences. Our learnings are mainly, I think, add DB implementation behind an interface, which means that if there is no interface, which means that first we need to do the refactoring, so we can put it behind and we can actually segregate the service thing and DB thing. If there is some interface already, then it will be hard. Like if it's a case of data migration, you can write the different implementation for that, but tomorrow if you plan to change your database altogether, then that too as well, I think very easy if you put your DB implementation behind an interface. So your service is not actually getting impacted if anything that you plan to change in your DB side. Next thing is business logic should not be there in your DB layer. Like if we keep that business logic in the DB layer, what does that mean is either you need to replicate it on the new implementation that you are writing, or you need to first refactor that you put the business logic in the different a layer before that interface, or you replicate that same thing. So it's always a good practice that we have business logic segregated, so we are only doing the code operation on the DB layer. The next thing is every step should be reversible. So if there is any impact, it should be very easy for us to roll back those changes. If not, it can have a huge customer impact. So every step that we do, either it's enable writes, enable reads, it is okay to redo the step instead of having any customer impact. So yeah, every step should be reversible. Strong framework for alerts and dashboards to detect any anomalies. And if anything goes wrong, then we just get to know ASAP instead of we get to know if there is any customer impact. Having a pre-production environment which is close to the production environment for testing. Before we start doing some testing, before we actually start dealing with the huge data, it should be good that first we test it in the lower environment, which is very like the instances, the DB instances should be very similar to the production one, but if there is an impact there, if there is something which is not working, then there is no customer impact if we actually get that same thing tested on a lower environment first. The last thing is robust testing strategy. So we were having enough tests which were giving us enough confidence that whatever that we are doing is something not impacting any customer. So unit integration was normal, but we also had the functional test to know how our new implementation is working. So we wrote the test with the feature flag value, changing it as per our different rollout steps. And yeah, so these are the few learnings. So we are done. We are good to take the questions, if there are any.
You mentioned during the dual reset phase you'll have a fail-safe mode, right? So if there's a problem, it doesn't show that to the customer.
Yes.
How does that work? How do you guarantee that an error doesn't propagate back to the...
So in that case, let me show you. Wait a minute. So in this phase, if you see that you are doing dual read write, you will be having some feature flag to see if it should be reading the data or if it should be reading in the fail-safe mode or not. If you are in a fail-safe mode, you just read the data or write the data, and if there is any error, you just log it here.
Okay.
And ultimately, you are returning the data, all data, to your system, to your users, instead of we returning the new data. So here as well, once it is done, we log this thing. We are also doing the comparison. If the data is same, then we are good. If not, then again we will be having the alerts in this case to make sure that the data is consistent or not. Similarly, I think once we get confidence here, here if you see we are only reading the data from the new database, and accordingly that we will also do the same comparison and logic with the new database. And once we get the confidence in this phase, again we have a feature flag to decide if we should be returning the data with the new database or the old database, and depends on that we will be returning. So this logic that you will see is not something very good in shape, but just think about it. I think this is something will remain here only in that phase. Once this is done, I think you can completely get rid of this dual read-write implementation, and you can simply keep only this new processor that too with the interface. So tomorrow, if anything happens, it should I think it's always a good practice to have the interface in place.
So then basically it falls back to the old data, this error. And you're also, I can see you're comparing the new and old data.
Yes.
So doesn't this add some latency to every single?
I think it will have the latency impact, but if it is under what it is under our SLAs, then this is something that we can do along with the call. If we think that otherwise, I think just a simple JSON comparison, it won't take that much time. But if you still think there is some impact, we can decide to do it in the async mode. So we just return the data to the customer, and we are keeping this logic on async mode. So the latency is not actually getting added up in the request. Yeah. Cool. Any other questions? Yep.
Are there any changes that you would do if there was a read-heavy operation, an operation that's read and write-heavy? Are there any changes that you would do in this approach?
I think our first use case was majorly read heavy only, because as compared to the media that is being uploaded in the system was less as compared to how much it is being readed. So I think it worked well in this case, but like mostly I think it's not about how much, if it's a read heavy or write heavy. It's mostly about what kind of data verification that you want to do. If it's a read heavy, I think you will get very good confidence during this phase where you are actually comparing the data. And if it's a write heavy, again, you are doing the similar thing here. Like here as well, you are comparing. So I feel there should not be having any impact if it's a read heavy or write heavy. Yep. Any other questions? I think we are good.
So I want to ask about that bulk data verification job.
Mm-hmm.
You said there are billions of rows, right? The table that you
Yeah, they were.
Doesn't that take very long?
So that's what I told now. We were doing that bulk verification for some batches. We were selecting some random data instead of we select all the data, because I think if we select all the data, that will be the reoperation what exactly we are doing. So in the first use case where the data was simple and we were using that third party, we actually tested with a very small data set just to understand if the DMS is working or transferring the data as per our expectation. Once we get the confidence with a small database, I think we relied on DMS to see that this is working as expected. But again, we wanted to just see that there is also data integrity, like all the data is actually being transferred to the destination database. So for that purpose, we actually ran that job where we are actually selecting the random data, because the live data you can get the confidence because you are doing comparison with the every read, right? But for the data which is not changing frequently, for that I think we so every day in the different phase of this migration, every day we were running those bulk verification jobs to read the data from source to destination and doing the comparison. The comparison logic was, I think it was exactly same how we were doing with the live data.
When you're doing the migration, how do you do it table by table? Because I'm guessing you can't just insert it all at once, because there'll be some foreign keys and you have to maintain that reference.
Definitely. So in first use case, the table were, because we were migrating from SQL to no SQL database. So in no SQL database, you don't need to worry about the constraints, if there is any cross table constraints, because that was how their use case was. But in other case, yes, we were doing some kind of joins within the table, and then we were migrating the data to the other database. So the operation that we wrote is actually taking care of reading the data from the different database in that transaction, doing the joins, and we were also having a lock in place. So we are the data that we are changing is not something which is impacting the like which like it is not something which is actually getting changed. And this we were giving a higher priority to the live data transaction as compared to the bulk migration, because bulk migration is something that we were controlling, and if anything goes wrong, then we can correct the data. But if the live operation is something is getting or feeding the data wrong, then we will not having anything to compare what was the data. So this is how we actually planned. Yeah.
Okay, one last question.
Yeah. No worries.
When, I think you might have mentioned this, or you might have said me. So when do you start reading from the new database? Do you read the entire migration for the first copy to finish, and then you set it to dual read, or do you do that when live?
So in case of SQL database, where we were confident that DMS is working as expected, we first migrated the data from source to destination, and we also tested the integration code in lower environment. That's the another reason that we first did the DMS migration, and then we enable the dual read write. But in the other scenario, where we first wanted to test the live traffic, because and also we don't wanted to redo the data migration again and again until or unless we are not confident the live data transaction that we are doing is working, because otherwise it will be a rework. We will need to clean up the data. We'll have the data inconsistency if the live traffic is actually not doing work as per our expectation. So that was the reason first we actually tested the live integration thing, and then we actually did the data migration. During the live integration, we were also maintaining the status for every record if that data is migrated, so we don't redo that same thing during the bulk migration.
Okay. And in the live migration, what if, say, I'm doing a read operation and that read resource doesn't exist in the table? How is that handled?
If the resource is not there in the destination table or the source table.
In the destination, so it's not yet migrated, but because you're doing it live.
So yeah, like obviously, because you in that phase you will expect the data is not there. Because you know that all the data is not migrated, so you will write the code in that phases, that in that phase we will get the mismatches. In that phase we will keep running our service in the fail-safe mode.
Okay, so
Yeah.
just
So if there is any failure, then we are fine. We all anyway have the old data set to actually return to the user. And after we migrate all the data, once we know all the data set is there on the destination, then only again we were keeping it for a while to do the comparison. Once we get the confidence, then only we were actually started relying on the new data set. Yeah.
So when the failsafe happens, does it fall back for this request and all requests after that, or is it only for that specific request?
I think so. If that failsafe happens now, so it just return that the data. Like if there are, for example, so mainly this operation, if there are multiple reads needs to be done in the database, no. If it fails to read for first, like if for example if it fails to read with the source data set, it will not be even try to read with the destination data set. Okay? If it is success with the source, then only it will try the destination. If it fails with the destination, it will just log the error and return like whatever is required. So all the just to answer, if there are multiple reads needs to be done in the old database, we were first completing all those reads with the old database. Then only we were coming to the new database. Where is that? So here, if you just see here, first like this this write is actually taking care of all the transaction that is required. Okay? After that, we will do the same operation with the new thing. So if there is any transactional between the old thing, it is completely taken care within this. Yeah? Any other questions?
How much overhead have we seen in the migrations?
Overhead in terms of?
In terms of reads and writes to the old and new database.
I think it's not an overhead, it will be having the latency impact. You will be making sure that you have enough dashboards to see if there is any failures. And mostly I think it's the rollout phase that you need to be very careful. So you can sense if there is any unexpected. And mostly I think we were making sure that everything that we are doing is behind the feature flag. So there is no impact until or unless we get the confidence. So this piece of this thing is something that we were writing enough test, to actually get the confidence that whatever we are doing is as planned. And we were also having proper runbooks in place. So we see or we capture the different steps, and it's very straightforward. If there is anything wrong, we were maintaining those logs and just completely turn off the feature flag. Don't worry, like anything wrong, turn off the feature flag. We'll identify. In every step, we were making sure there should not be any customer impact at all. Yeah.
Was this two-way migration? Within that is till the time my system's primary source of truth is the old database.
Yes.
It would migrate. It would also replicate the data in the new one.
Yeah, that's correct. So.
And for a while, when my source of truth is going to the new database, just for the fallback, right? It is also going to.
Yeah. So till the last step. Till the last step here, if you just see, until we are not confident, we were relying on the old thing. Like if anything wrong, like we were having proper try catch, we should be easily for us to actually roll back. So in the different phases, it's not like that if we want to roll back, we just go to first step. No. If we fail in 6 steps, we just go to 5 steps. And once we get confidence in until this step, then only we just go to the first step. And the last, sorry.
And that was possibly because, not because of DMS. DMS is only one way.
Yes.
DMS cannot be.
Yeah, DMS is only one way, because that was a use case. But I think the traffic as well, if you just see, the existing infrastructure was mostly focusing on keeping the data on the old data source. There should not be any data inconsistency within the new old data source. We were never giving the priority to the new data source until we get the confidence.
And there was a time in between this where it was actually writing to both the data.
Yeah. This is these were the very few initial steps, where because as soon as you actually did the DMS data migration, and as soon as you see that your CDC is also done, you will enable your feature flag to actually start writing to both the database, because DMS is expensive. You can't just keep it running for infinite time. So once you migrated the data, you will just stop. Before you stop that, there will be some overlap between the dual writes that you are doing and also within the CDC. Once we get confident the dual write is fine, then only we just turn off the DMS thing, so it stop capturing the data, because this is same thing which is being captured with our live integration.
So, one final thing. So, when your data layer was actually writing to databases,
Uh-huh.
right, was there an impact on latency?
Yes, because it was a synchronous task. There will be some impact on the latency, because initial phase you can decide to not have it, but we don't want it to complicate this thing. What we wanted is we just change the feature flag value and just keep the code as it is, and we were keeping both the operations synchronously. And there was some impact on the latency, but because that was under our SLA, so we were okay with that. Yeah. Cool. I'll just stop the recording.